Hi, in this lecture I want to start by introducing GIS to make sure we're all on the same page about what it is. And then I'll get into the specifics of the QGIS project. So what is GIS? Well, first off, it's an acronym. It stands for Geographic Information Systems. So it's software or an app. And it's software that can work with spatial data files. As such, it also allows you to make maps and conduct spatial analyses. And a spatial analysis is, in its simplest form, just getting information out of the data. For example, measuring distances on a map or creating heat maps. So let's talk about the software for a moment. GIS software has a lot of capabilities. It's able to read and write many different file formats. So these are files that have some kind of georeference, meaning the software can place the data on the world in the correct place. GIS software also has a lot of capabilities that you find in database softwares such as Microsoft Access or MS SQL. It has a lot of graphic and artistic features that you might find in Photoshop or Illustrator. And it has tools for working with spatial data and analysis tools for manipulating that spatial data or editing that data. So QGIS is open source. So let's talk about that. What does open source mean? Well, free and open source software, that term mainly has to do with the license. So on one side we have a proprietary license. So you might think of Microsoft PowerPoint as a proprietary software. And so the license, when you purchase PowerPoint, restricts your usage in some way, either in the time you're allowed to run it, the number of features you have access to, or the number of computers you can install it on. This is contrasted with an open source license, which flips this around and actually grants you rights and freedoms as the user. For example, you'll have the freedom to run the program as you wish for any purpose. You can study how the program works. So this is the open source component, access to the source code. And for most of us, this may not be the most important portion of an open source license, but it does allow you to study the program, how it works, so that you understand what's going on and improve it if you need to. You're allowed to redistribute copies so that you can help your neighbor and distribute copies of your modified versions to others. So what does free mean? So there is a monetary cost. I think most people associate the fact of an open source software like QGIS, you can download it without paying a licensing fee. So that's monetary cost. But free really is referring more to the word freedom. So you have the freedom to use the program as you wish. It also happens to be free of licensing costs, so it is both of those things, an open source software. But there is a cost to learning it. So we all have to learn it, as we're doing in this course, learning how to use it to do vector-borne disease surveillance. And there's also participating in the community. It's a community-based software. And so whereas you don't have any monetary obligation to pay a licensing fee, the dynamic in the software is that once you download it and start using it, you are part of the community of that software. And so as such, if you run into a bug, for example, you can report that. There's mechanisms on the QGIS's website for doing things like that. So participating in the community is an important part of using an open source piece of software, because that is where your support is going to come from. So let's talk about some misconceptions. There is this thing called FUD, fear, uncertainty, and doubt. And this was propaganda spread in the 70s and 80s by corporations like Oracle and Microsoft and IBM. And see things online where the documentation is poor for an open source software, or the support is bad. For QGIS specifically, you still see things on the listservs like all your data will become open if you bring it into QGIS, or you're not allowed to sell maps or data produced in QGIS. So none of these things are true. The documentation for QGIS is quite good. The support is fantastic. The fact that QGIS is open source has no bearing on your data. You can bring proprietary data into QGIS and keep it in that proprietary format and not share it with others. And you're perfectly allowed to sell maps or data that you produced using QGIS. So we are going to be using QGIS 3.16 in this course. As of the recording of this video, 3.16 is not out yet, so I don't know what the actual name is. But if you've already installed QGIS, you can go now to open it and go to the Help menu to About, and you'll see this window pop up that actually is the software license. So this is just what I was talking about. This is from the Free Software Foundation, and this is the license that QGIS is licensed with, the GNU General Public License. And so you can read here about all the freedoms that it's granting you as an end user. Okay, so that's what open source software is and what GIS is. So let's dive into QGIS a little bit. And first of all, how do we pronounce it? Well, they did take a poll once, and at the time, most people said QGIS. A lot of people, like me, just say QGIS. So there's really no correct way is the take-home message here. You can pronounce it however you like. There are even many people now who just call it Q for short. So one of the benefits of QGIS is that you can run it anywhere. It'll run on Windows, Mac, Linux. You can even install it on a Chromebook. It's not as straightforward, but it's possible. And there are apps for data collection for both iOS and Android. And it's 64-bit, meaning it's quite fast. So as I mentioned, QGIS is an open source project, and it's an open source project under this organization called OSGeo, the Open Source Geospatial Foundation. This is a nonprofit organization that has a mission to foster global adoption of open geospatial technology by being an inclusive software foundation devoted to an open philosophy and participatory community-driven development. So OSGeo is a small nonprofit with just a volunteer steering committee, and their goal is to bring in lots of different open source mapping softwares to make them all work well together. So you can go to osgeo.org to read about that organization more. But the organization has a lot of softwares under its umbrella, in air quotes. So we're going to be using QGIS, highlighted in red here, but there's a lot of other open source mapping related projects out there other than QGIS. So QGIS is in the category of desktop applications. There's also another one called GRASS that's very popular. There are libraries. We'll talk a little bit about these. A lot of these are built into QGIS. There are spatial databases. There are content management systems for serving data. There are web mapping projects for making interactive maps, thinking of like Google Maps, and metadata, data about data. There's projects related just to metadata. So there's a lot of open source geospatial software out there. Turning our attention back towards QGIS. QGIS is a software, as we mentioned. It's a GIS software. It's also a community. This is a photograph from the QGIS user meeting in A Coruña, Spain in 2019. And so in this picture, you're seeing a lot of the core developers and power users of QGIS all assembling to work on the project over a couple days. So QGIS.org is a nonprofit registered in the country of Switzerland in 2016. And there is a project steering committee for the project. And this is a group of 7 people who are elected by the community. And they're there to steer QGIS to make sure it's heading in the right direction, that it sustains a good standing in the geospatial community, coordinate activities of the project, do a little marketing and case studies and things like that. So it operates as a democracy. So they just deal with issues that come up for the project. So the important thing to think about here is that there is no corporation behind QGIS. There is no for-profit business making money. Almost all the people involved in QGIS are either volunteering their time or working for a company that provides services using QGIS. So I think it's an important dynamic in an open source software is that there's no for-profit motive behind it. The project itself, to keep things organized, has regular meetings. With COVID-19, these have all been put on hold or have become virtual like everything else. But there are developer meetings, also called Hackfests, and there's 2 of those per year. And then there's also a user conference annually. And this photo is from the first QGIS conference in Denmark in 2015. So the version that we're going to be working with is either going to be 3.14 or 3.16. I believe I'm actually going to have you work on 3.16. Each one of these versions is named for a city where a development conference was held. 314 pi was named because it is the numeric equivalent of pi, the mathematical variable. So there's always multiple versions of QGIS available. We're going to be using one called the stable release 316. There's also usually a long-term release, which is currently 3.1. So there's also a nightly master. You can actually install every single day the nightly version of QGIS with the very current changes to it. And I wouldn't recommend that. For most people, we recommend they either use the long-term release or the stable release. But on a Windows machine, you can actually have all three of these running simultaneously without any conflicts. QGIS does have a very rapid release schedule. So every 4 months, a new version comes out. Because of that rapid release, every spring, they coin the latest release, the long-term release, and that is maintained for a 12-month period. So that's what most people are going to be recommended to use, the long-term release, because you can install it in the spring and just be sure that it's not going to have any new features or changes throughout the year. So in terms of support, I mentioned this comes from the community. So one of the best ways to get support for QGIS is by the mailing lists. So there's a user mailing list. You can go to this URL to find this and just enter your email and name to subscribe, and you'll get a daily digest. So this is how the help works. When you have a bug or you run into an issue with QGIS or don't know how to do something, you can obviously Google it and try to find answers online. But if you want to directly interact with the QGIS community, you would pose a question to the user list and describe your situation and what you want, and it would be the members of the community helping you. There's also lists for the developers of QGIS, one for the community team that organizes meetings, one for the project steering committee, and one for the QGIS web client. And so these are all open. Anyone is welcome to join any of them, but for most people just starting out, the user list serve is the most appropriate. One important dynamic of an open source project like QGIS is you can think of it as a duocracy. So what this means is that if you need a change to QGIS, for example, if you see a feature missing, if there's something you wish it would do that it doesn't do, you can sponsor that or program it yourself. Most of us aren't programmers, but so in that case, maybe the most appropriate way is just to contact somebody on the developer listserv and describe the new feature you want. And it may be that someone's already working on it, or there may be other people interested. This animation that you're watching has to do with my personal experience doing this. This is a raster image of vegetation types, and it used to be many years ago that there was no way for QGIS to efficiently render and give every type of vegetation, in this case, its own color. And so, to make a long story short, myself and several users pooled our resources, contacted a developer, scoped out the work, and we all collectively, about 10 or 12 of us, donated a little bit of money to get this feature into QGIS, and it was actually done within 3 weeks. So you're not paying any licensing fees. So when you need to have a new feature built or something like that, it's usually fairly affordable. And since you're not paying any licensing fees already, you know, it's not a lot to ask to have that. And then everyone benefits from the change that you needed. And that's basically how QGIS grows from release to release to release, is people working with it in this way. So there are plenty of ways to get involved. Obviously, programming and development of the software is the most obvious, but QGIS is also translated into 48 languages. So there are people in different countries working on translating the interface to QGIS into their language. So that's something that people work on. The documentation is also done by largely a volunteer effort, so anyone can contribute to the documentation. As I mentioned, you can sponsor new features. If you run into a bug in the software, we get an error when you're trying to do something, you can file a bug report. That way the developers know about it and they'll fix it. And there's also user groups. So there is a QGIS US user group, and these national user groups are just ways for people to stay connected in your local community. So you can even form a regional user group on an island or in a city. So there are plenty of examples of those. So the software itself is going to look like most GIS softwares. When you have some data loaded and you're going to have a map display taking up most of the screen space. There's going to be a layers panel that shows all the different layers that you've brought in. There's toolbars across the top, some for panning and zooming around the map. You have your standard menus that you'll learn as you work through the software. And there's a processing toolbox for running tools, and we'll use some of these processing tools as we go through the course. So as you start adding data to QGIS and you style it and you save your QGIS project, like this one is called Hewlett Map, the project gets saved as a .qgz file. It's the same thing like when you open up a Word document, you start typing and then you save it as something, it gets saved as a DOC or a DOCX on your hard drive. So a QGIS file is a QGZ file, and it doesn't store the data in that file. It's just storing the locations of that data on your computer and the colors that you made, all the layers and things like that. So QGIS is a very powerful package because it's not just a single project. QGIS is kind of a central project that has lots of other open source projects under the hood, if you will. So there's QGIS, and then there's another project called Proj4 that deals with coordinate systems and projections, and that's how QGIS handles those. So that's built into QGIS. There's two other libraries, GDAL and OGR, that are set up to read and write raster and vector formats. This is one of the most probably widely used geospatial libraries in existence. It even gets used in proprietary software like Esri. So this is built into QGIS. I mentioned GRASS earlier. It's another desktop GIS. QGIS has the GRASS tools built into it, so you can use the GRASS processing algorithms in the toolbox without having to learn or install GRASS separately. Same with Saga. It's another open source desktop software, and its processing tools are also built into QGIS. So you can use QGIS basically as a front end to access all the functionality in these other softwares. Makes it very easy. There's also some spatial databases where you can store your data in an enterprise database. And so these are also incorporated with QGIS as well, PostGIS and Spatial Light. And when you combine all this together, it becomes a really powerful package. So this slide talks about the interoperability via that GDAL and OGR libraries for reading and writing data. We're not going to go through all this. This is just to kind of show you the absurd number of spatial data file formats that QGIS can read. So we're going to talk about what vector and raster data are. But for vector data, it's the most common thing that we'll work with, points, lines, and polygons. And so the thing to note here is that QGIS can read and write the proprietary Esri formats just fine. It'll also read 88 raster formats. And over here on the left, we're seeing the different databases and web services that QGIS can read, including ArcGIS map services and ArcGIS feature services and lots of others. So it is really like a Swiss Army knife. It will read almost any kind of data that you can throw at it. QGIS also has a very robust geoprocessing environment. And this is really, when I say geoprocessing, I'm talking about analysis and manipulating spatial data. And we'll use a lot of these tools as we go through the analysis of vector-borne disease and mosquito data. And on the left, you're seeing the toolbox for QGIS, a little animated GIF of the toolbox. So you can see that there's little categories of tools, and in the toolbox there's several hundred. You can actually search for tools at the top as well, so you don't have to memorize where things are. If you need to find the clip tool, you just type clip into the search box and it will filter the toolbox based on what you typed. There's hundreds of tools in there. You can see the other tools from GRASS and Saga there as well that I talked about. It has a processing modeler, which we won't use, but this is a way to set up an analysis that starts with raw data and goes all the way through to a completed stage, and set it up in kind of a visual manner where you're adding data, adding a processing algorithm, getting the output, feeding that into the next algorithm, and you can create your own custom tools with this. You can also batch process. So for example, if you need to clip a whole bunch of layers, you can run the clip tool in a batch mode shown here. And it has a Python console. So Python is kind of the most popular geospatial scripting language, and QGIS has a PyQGIS API and a console. And we're not going to be working with this either, but I just want to let you know that there's a lot here that you can learn as you go forward and begin to master your skills with QGIS. So this slide is a little less technical. It's just talking about how intuitive QGIS is. So with most softwares that do GIS, you can go into the properties of a layer, go to a symbology tab, and adjust the symbology for that layer, change the colors of it, if you will. QGIS, though, has a really nice feature called the styling panel, or styling dock. And this is a panel that opens up on the right-hand side, and it gives you access to all the styling functionality that QGIS has. And the nice thing about this is that you can sit there and tinker with colors and the way the layer looks and see the result immediately without having to click OK. So you can find just like the perfect color quite easily. You can just tinker with things until it looks on the map the way you want it to look. QGIS also has some fantastic capabilities. This is a kind of data called mesh data, which we're not going to be working with. But for many in the Pacific, this mesh data can be used to show tropical cyclones really effectively. This is a data set from the 2017 hurricane season in the Atlantic Basin when we had the 4 Category 5 hurricanes go through, like Hurricane Irma. And we're showing this with traces, so it's a really intuitive way, but we're also seeing it through time. So QGIS now has this thing called the temporal controller, which we will get to work with. And anytime you have data that has a time component, you can animate it with this temporal controller. So this weather data that shows the wind speed through time over the month of September 2017, we can animate with the temporal controller to create an animation like this. So we will be working with the temporal controller a bit near the end of the course. So thanks. Hopefully that clears up a little bit about GIS, what open source software is, and the QGIS project. And as you go forward, the next steps will be to install the software, download the data, and begin Module 1.